All right, guys, we're going to be doing arrow penetration tests. This time we're going to be doing something a little different. So we'll be doing some videos on sectional density, obviously a lot of penetration tests. We want to maximize penetration. From what I've researched, it seems that penetration, the more penetration you get, the better. So with that, I was thinking to shoot as small a diameter shaft as possible and as heavy a shaft as possible. That would maximize sectional density. Something that's really small surface area that weighs a lot is gonna push right through whatever it hits. As long as it's flying straight, obviously. But a small diameter shaft isn't gonna do you much if the broadhead is too large, right? You can have as skinny a diameter shaft as you want, but if that's what you gotta push through an animal, you're gonna have a little bit of resistance. Granted, it's kind of contact, single bevel, two blade, but you're still gonna have more resistance than, per se, something that's just a hair bigger than the shaft, right? I mean, what's gonna be easier to push through an animal? I would think this one is, right? Other than this. So why are we shooting these wide broadheads? It seems to me if you're trying to make a bigger blood trail, you do that. But if you're trying to penetrate deep, very deep, why not trim it down? I mean, is it not true that a field point can, properly placed field point can take out an animal? So we're gonna try this. This is a Grim Reaper mechanical broadhead that I Frankensteined, as it were. I stripped it. So we took this, it's that, not carnivore, but Fatal Steel, I think. 3-blade. It's shorter blades. We removed the blades and the black plastic there, and we turned it into this to maximize penetration. So, maximizing cut, maximizing penetration, right? So it seems to me if we could create broadheads with a very small frontal surface area, just a little bit, you know, at least 5% bigger than the shaft diameter, then essentially the sectional density will be in our favor as long as we have that frontal surface area small enough to match somewhat close to the diameter of the shaft. I feel like that is going to give us a lot better penetration than even using a single bevel kind of contact broadhead that's over an inch wide. So the goal is, if we can narrow down the frontal surface area of the broadhead, it seems to follow that we wouldn't really need fletching, would we? Because fletching impedes penetration, does it not? Creates friction in the back as the arrow's sliding through the animal. So we narrow the front broadhead, right? Because mechanicals fly like field points, as it were. But this is a mechanical without the blades, just the razor tip. It's basically a field point diameter. Therefore, we wouldn't really need fletching, since you can bare shaft tune a field point arrow. You don't need fletchings. You can't bare shaft tune a broadhead that's over an inch wide. It's like wings on the front. It's gonna fly crazy. So if we can minimize the diameter of the shaft, match it with a cut on contact head, and remove the fletching, ideally we could get extreme penetration, and we wouldn't even need to increase the arrow weight that much, but we can. So we're gonna test this out. We're gonna go put it up against 8 jugs, see if it zips right through. It is a little bit on the lighter side. I don't have much weight in here. Let's weigh it up and see here. Yeah, we're only at 500 grains. So yeah, not too much, not too beneficial on the weight, but we will shoot another arrow in our next video that is much heavier. It's a smaller head, and we'll take off the fletchings. And I think this one weighs 1,300 grains. Let's see. $1,476 grains, almost 1,500 grains. So ideally that's going to give us a lot more penetration with the small diameter, much more mass, increased momentum. All right guys, so I took the fletching off. It's the bare shaft. Took the mechanical blades off. There's just the razor tip. See how she spins? Not bad. All right, let's go see how well she penetrates. I got the purpose of shooting such a narrow broadhead like this. It's not too. It's not that we don't care about cutting diameter and want a bigger cut. I'm just saying to maximize penetration, if we're just to test the limits, what do we need to maximize penetration? There's a lot of broadheads out there that are maximizing cutting diameter. I want to see what a broadhead looks like to maximize penetration, and I think this is going to be key. So let's go ahead, run it through, no fletching, bare shaft. See how she does. Shooting the PSE Omen as usual, 31-inch draw, 80 pounds. Definitely veered off to the right, so let's shoot her again. There we go. Well, we went through all of them. Just had to shoot it 3 or 4 times, so it's definitely, it's not very stable, I guess. Yeah, 3 shots. That one definitely went through the last one there. You can see this nice hole in there all the way through. Stopping the target pretty good. To the bottom there. To the bottom there. So we were losing water, but it's a small hole, so it definitely was it's taking a while. There's 8, 2, 4, 6, 8. That's pretty incredible. I ran the sectional density numbers for on our previous penetration video where we had the FMJ dangerous game. Definitely out penetrated the other two. The sectional density for that was about 1.5, and the sectional density for this arrow with the small diameter head, 0.231 diameter shaft, Black Eagle X impact with 0 fletching, so it's pretty streamlined. Sectional density was, it's 500 grains, sectional density was 1.3, so it was a little bit lower. It seemed to if we could get it to go straight through the jugs, it seemed to do just as well as that FMJ Dangerous Game at 420, 30 grains lighter. So something to think about. Obviously, I think a little more weight would have made it a little more accurate. So something to keep in mind. Hope you enjoyed the video. Give us a like and a subscribe. We'll catch you on the next one.